a little bit more advanced. So now we're going to go into a little bit more on the data.
We are not going to talk so much about Copernicus products, actually. We are going to download a few products and we are going to make computation over the products, right? Well, in this tutorial, we are focused in the problems that you, in one specific problem, we decide to go over one specific problem that usually affect the ecosystems, which is the case of coral bleaching. You know, this coral bleaching is sometimes produced by some variables like the temperature of the water or the pH of the water. The coral bleaching doesn't directly kills the coral, but it's in a state where the coral is clearly affected by harmful conditions in the environment. So to explain, as I said before, this kind of events are usually associated with the temperature of the water. So in this case, we decide to do some analysis of the event that occurred in the Caribbean Sea in 2005. This event was very important, and it is very well referenced event because there are lots of papers about this event defining what happened in that time, the period of time, the region that was affected, etc. This event affected the eastern side, mostly affected the eastern side of the Caribbean Sea, as we will see later. Well, we want, obviously, Copernicus services cannot provide direct information of coral bleaching like these pictures, because this is work that has to be done in the field. But for example, Copernicus services, they can provide information like chlorophyll in the water or temperature of the water that could be good information sources that could give you information about the state of the ecosystem, to evaluate the state of the ecosystem and the health of the ecosystem. As I said before, these coral bleaching events are very related with the temperature of the water, and as you probably know, nowadays the way we analyze the high temperature of the waters is using the definition of marine heat waves. Marine heat waves are periods of time where the temperature of the water is exceptionally high. Here I have a diagram took from Hockey et al. 2016. You can see here, for example, we have in red the temperatures time series in a specific point, whatever it is. And the blue line is it would be the mean value, the climatic mean value for a specific day of the year, the specific days of the year. And the dotted black line represents the 90th percentile of the climatic variability in this specific day, right? So we define marine heat waves right now in scientific communities. The marine heat waves are defined as periods of, well, we can be bigger, longer than 5 days, or these are parameters that can be modified, that where these periods, the temperature of the sea sea surface temperature is higher than the 90 percentiles for a period of time. And this period of time has to be longer than a specific threshold, because if it is not longer than a specific threshold, we do not consider this as a heat wave. We consider it as heat spike. It's just a punctual surpassing of the 90 percentile, right? Well, what we are going to do in this tutorial is to download some data from Copernicus services and see what happened in terms of marine heat waves in the Caribbean Sea, in the region affected near Barbados and Virgin Islands. So we want to see what happened with marine heat waves in 2005 in that region and see if it could have some relationship. Well, according to the bibliography, yes, it has a lot of relationship. There are lots of information in literature about the relevance of temperature, sea surface temperature in that period in relationship with the event of coral bleaching in Caribbean Sea, right? Well, I would say before continuing, the intensity of a marine heat wave can be defined in using different parameters. For example, you can define how intense is a marine heat wave. You can define the intensity of marine heat wave as the maximum temperature. It would be okay. It would be a possibility, but you could also consider the intensity of marine heat wave as the length of the marine heat wave, the time it is affecting. You can also consider the ramp, the ascending ramp of the marine heat wave as an indicator of the intensity of this marine heat wave. You can also, there is another option, which is the integral of temperature between the accumulated temperature of the marine heat wave from the starting to the end of the period, etc. There are many parameters that we can use to define how intense is a marine heat wave, right? Well, as before, first of all, we have here a cell where we are defining the libraries we are going to use in this tutorial. Not much new in this cell. We are using again NumPy library, XRI, Matplotlib for plotting, Cartopy for plotting maps, and also since we are going to need to work with we are going to manipulate a lot of date formats. We are going to use DataTime library, which is a DataTime that provides some classes to switch between different formats of dates, right? Here I let you some information about marine heat waves, coral bleaching, and the events of 2005. Very interesting if you want to follow this tutorial and also improve get more information about this event. And well, as before, we are going to start with downloading the data we are going to need. Well, in this case, we are going to download two different data sets. Both data sets are obtained from satellite data, reprocessed data, L4. They are data, global data, so we have data for the globe. And as you can see, we are going to download data, the same product, but we are going to download two different files of the same product. In one case, we are going to download a file for 2005, and not even full 2005. We are going to download some data for the summer 2005 and use a quite wide window a quite big window of latitudes and longitudes. And after that, since we are going to compute the 90th percentile of temperature, to compute that, we need a very long time series to be able to compute a robust 90th percentile, right? So we are going to download another data set that goes from 1990 up to 2021. This is 30 years of data. So since we are downloading 30 years of data, in order to keep the size of the file not very big, we are going to download a quite small window, geographical window, so we can go over a specific geographical window getting a very, very long time series. Well, as I said before, this is the same than before. You can download this data through the Copernicus services webpage, through the Copernicus Marine Data Store, or you can go over to the Copernicus Data Store and in the API request get the information of MotoClient and use these two commands of MotoClient. So you just have to run these two options. Since we already have this data here, I am not going to run this cell. I encourage you to run this cell and see how they work and see how big are the files downloaded and how many time it takes to download it. Well, first of all, once we have the once we have the data downloaded, we have two files. The first thing we are going to do is have a quick view of the marine heat wave, the surface temperature in the Caribbean Sea in 2005. To do that, we are going to open this data file, which is the data file that has all information for Caribbean Sea in summer in 2005. And as before, we open this data file with the XRA function, open dataset, and using the path and the name of the file. And we create an object, DS, which is the object through it we can access all the data, right? Well, as I said before, these files have dimensions, attributes, and variables. This is the data file we have opened. You can see we have 500 latitude values, 800 longitude values, and 62 time steps. And here, as different than before in the previous tutorial, we are only downloading one variable because we want to keep the size of the file not very big, right? So we have selected just one variable that depends on three dimensions. We are not including here depth because these are data, surface data. And so since they are data from satellites, most of them are surface data, so we do not have depth dimension here. Well, and as first example, this is not as much different than before. I'm going to run this cell. We are going to make a plot of sea surface temperature in the region. This plot map function is almost the same function we defined in the previous tutorial. It's a very simple function where we are creating a plot in a specific figure and axis. And this loop is just a loop to create a map, a sequence of map, the movie of how it was the sea surface temperature. You can see we are looping, we are doing a for loop over the DS time. So we are going over every time step, but we are skipping some time steps. As you can see, we are plotting every second value of time step, every second time step, and the people who is related with Python code will know that here we are using different plots. So we are making an array of plots with the different maps, right? For example, here we have for the 15th, 17th, 19th, 21st, etc. And well, we can have a look, first view of the a first view of the sea surface temperature in the Caribbean Sea and also the Gulf of Mexico. And we can see that, well, at the beginning, the temperature in the Gulf of Mexico was quite high, very high, actually. But with continuing the movie, we can see that in September, we start to have very high values of temperature in near around Cuba. But looking at the eastern region, that is the region most affected by this coral bleaching, at least according to the literature, we can see high values of temperature, but actually they aren't as high as they appear to be. For example, the values of temperature are higher, for example, around Cuba or here or in the Gulf of Mexico. So what happened? There was a problem here. There is, well, this is because we are defining the marine heat waves, right? Because maybe the absolute values of temperature are not so high here in the eastern coast, eastern side of the Caribbean Sea, near Barbados or near Virgin Islands. But actually, since if you compare these values with the climatology of this region, these values could be really, really high. Well, so how can we solve this? Well, so we can solve this using the definition of marine heat waves. So the definition of marine heat waves, we are comparing the values of temperature, not with in terms of absolute values, but in terms of compared with the climatology of the region, right? So let's go to an analysis of marine heat waves in Caribbean Sea, a proper analysis, right? So to do that, we are going to open the new data file, the other data file. As this is the other data file I said before, it has a very, very long time record. This file is, as in other cases, this file is just a cell to open a new data file that we will call again DS. So we are overclocking the previous DS object with this new file, right? We run this, and as you can see here, we have a file with almost 200 values of latitude, more than 100 values of longitude, but we have 11,000 values, more than 11,000 values of time, because obviously we have here, if we see the report of time values here, we have time values for every day, for the January 1st, 2nd, 3rd, etc. For daily value, we have daily values of surface temperature since 1980, January 1980 up to December 2021. So we have a very, very long time record. We need this because we need to compute the 90th percentile of everyday data in a daily means. So we need to have the longer time period because we are reducing a lot the data with this computation. Well, after this, we are including this cell where we are just selecting a point to work. We have decided to use this point, this location, but any of you can change the location you want to analyze. And I'm gonna run this cell, and while it runs, it takes a little bit because this cell is computing the mean of the data in the dimension time. So we are making a temporal average. We are making a temporal average of the data. So since we have 11,000 time steps, this takes some time in doing this mean. And well, as you can see here, to compute this mean, we just have to go over the specific variable in the data set and compute, use the function mean with the dimension we want to. So with this function, it's very easy to compute means along dimensions, for example, along time, temporal dimensions, latitude, longitude, depth. So, and as you can see here, we have to transform our data from Kelvin to Celsius. And well, after this, as you can see, the cell is still running. So as you can see, it takes some time. And well, here in this part of the cell, we are just making a little plot of the mean SST. We are using plot title mean SST. We are doing this kind of plot. You can see here we have the same region than before, but in this case we only see values of temperature, surface temperature for this specific region. As I said before, we had to reduce the window we are working on to reduce the size of the file. And here this X represents the point we are going to analyze in this work, right? You can change any, you can go over any latitude and longitude, but you have to be inside this region. You can try to download a new data set outside, for example, here in Cuba, and you can download another data set and change the data set you use here. So you can make an analysis of marine heat waves over any region in this window, right? Well, once we have defined this latitude and longitude position, and we go over the cell that specifically finds the marine heat wave events in our time record. Well, what we are doing here is from this data set that has a lot of time steps, we are going to select the time series over this location, and over this time series we are going to make the analysis to find these periods, right? The periods where the temperature is over the 90th percentile for a time longer than 5 days, right? To do that, we use this. Well, we are here. Well, we use this cell. This cell is a little bit tricky. Well, first thing we do is to import a new library. You see, marine heat waves. This library is accessible, open accessible in the Eric Olivier GitHub webpage. Just a second. This is one of the powerful things of Python that you can find. You can find libraries for almost everything you need in web. This library is very famous and very used in scientific community. We thank Mr. Olivier for publishing open his library, Marine Heat Waves. It has other libraries, and here you can find other all the documentation you need to use this library. And well, we have downloaded this library from Olivier GitHub, and we are going to use this library for the computation of marine heat waves, right? So we have here the file. You can see the computation of marine heat waves. This library has the code with different functions. For example, the function detect, which is a very important function here. This is the function we use to detect the events of marine heat waves in a specific time series. And it also has different other functions that we are not going to use here. But as you can see, these functions are quite long and specific. So we do not have time to program this here in this course. So we are going to use directly the function delivered by Olivier. So, well, the way we import a library is very easy in Python. You know, you have a file with the functions you want to use, marine heat waves.py. So to import this function, you just have to import the name of the file without py, and you can use a name for accessing the certain name for accessing the library, and that's all. Since you have imported the library, you can access all the functions inside the library using the name you have given to the library and access the functions inside, right? So first of all, we import the library, and at the end of the cell, we are going to use, as you can see, the function detect of the library to get to new variables. Well, what I'm doing here? Well, this is quite a problem in Python. There are many formats to handle with dates. So the thing is, when we get information, or when we get the data from Copernicus services, the XRI library works with a format, uses times as format using called datetime64. It's a format defined in XRI library, but to use this library from marine heat waves, we need to transform the format of dates into two different new formats. We need the dates in as date time objects, which is an internal date format for Python, and also we need date time ordinal object values, right? So this is what we are doing here, convert the time formats. You can see we are defining a function that gets a date in format data times 64, and we transform the format np datetime 64 to a datetime. And we are creating two new variables that are dates in format datetime and dates in format ordinal. So to compute, we get also the values we want to use for the computation. This data marine heat wave, this variable was defined before, selecting from the data set the latitude and longitude points we wanted to analyze, right? So data marine heat wave, maybe we can have a look of what is data. This variable, if we print the report of this variable, we see that this variable doesn't have latitudes and longitudes, and also only has the time dimension. So it has a time series over a specific location, latitude and longitude, which is 15 degrees and -60 degrees, which are the closest points to this requested point, right? Well, we can continue, and with this, we get the SST information from the data set, and we also have formatted or time vectors. So we just have to run the function detect over these two arrays, over these two vectors actually. And well, running this cell, maybe we could have a look. It is still running, but it finishes. We could have a look quickly. To this, we are getting these two variables or these two objects that actually are dictionary objects, Python dictionaries. If we print this marine heat waves object, we see that it is a dictionary with different levels, with different keys. For example, the time start, the time end. This is a list of the events detected in all the period, all the time record. The first marine heat wave event, the second, the third, etc. And it has, the dictionary has different keys for different parameters of every event. For example, the time starting, the finishing time, the time where occurred the peak of the temperature, the maximum temperature, the date of the starting, which is almost the same, but as I said before, in a different format. The finishing date peak, etc. The index in the time series. For example, it also has the duration of the marine heat waves. For example, here it is in days. So we have events that last for 6 days, and there is also events that last for 75 days and also 100 days, etc. Duration, we have many parameters inside this dictionary. I'm gonna remove this. And once we have this information of the events, we can start to work. We can start to see what happened in 2005, right? So for example, we can start to make some reports of what happened in 2005. So we can define a period of time, for example, from the beginning of 2005 up to the end of 2005. And in this cell, we are just selecting the events that occur in 2005 with using the function where from numpy. It's a very useful function to select elements inside an array. The elements that has the specific conditions. For example, we are selecting the elements in that where the marine heat waves, the starting period was less than this date end value, and the finishing period time is higher than the start period, right? So we are selecting the elements in marine heat waves that the array, the vector of marine heat waves that started in the period 2005, right? And after that, we have just a loop that goes over every event, writing a short report with showing the maximum intensity, average intensity, cumulative intensity, duration of the event, date of starting and date of finishing date. And you can see in the period 2005, we have found in this location 4 events with these specifications. One of them lasts for 10 days. The first one lasted for 10 days. The second one lasted for 92 days, 23 days, and the last one lasted for 75 days. Well, this report is interesting, but maybe it's better if we can plot something so we can see what happened in this 2005. So to do that, I did this cell where we are plotting. We are making a plot very similar to the one we saw before, but you can see here we have in blue the line of the climatology. This is the mean, the temporal daily mean of the values. In black, we have the temperature of sea surface temperature observed, and the green line is the value of 90 percentile of temperature, and the shaded pink shaded areas are the areas detected as marine heat waves. You can see here that clearly we have the first event, the second event, that it was about 82 days, the third event, and the fourth event. We can see here that, well, despite of the literature focus on the coral bleaching event in the Caribbean Sea, in the region that occur at the end of the summer, we can see that actually in that year the temperature of the sea in that period, in that location, was really, really high, almost since the beginning of February. So maybe the coral bleaching event, we could study if the coral bleaching event was not affected as much for the high temperatures in summer, but also for the sustained high temperatures all along the year. And we can also see that there is a peak of temperature near May that occur here. That is a very, very, very high value of temperature that occur in spring, early. That we could analyze if this peak could have something to could have a role in the process of coral bleaching that occur, or that is described at the end of the summer. Well, once we have this is interesting information. So from here we can start to continue with our analysis in different. We can get some conclusions and continue with our analysis. But we can also analyze other things. For example, since we have the list of marine heat waves in the full record, we can analyze the full time record and see what happened and see what the record of marine heat waves along for the last 30 years, right? So to do that, I did this last cell. You can see here, first of all, in the cell, we are defining a new function that is just a function that, like as we did before, we define a function to plot maps. Here we are defining a function to plot histograms. So this is a standard function that we have called bar plot, and we use the data in X, data in Y on the title, and the label in the Y axis. So, and this only creates a figure with axes, and only creates. Let's run this and let's see what it does. I think it's simpler. That creates a histogram where every line represents a marine heat wave event. So we can see the events located over the time record. And also we are plotting the maximum event. For example, as you can see here, we run the function bar plot For using the duration of the event, use the maximum intensity of every event, the cumulative intensity, and for every histogram we are plotting in red the maximum event according to this parameter. As I said before, we can define, there is not an agreement of what defines the intensity of a marine heat wave. We can define the intensity of a marine heat wave according to different parameters. For example, we can think on the intensity of marine heat wave as its duration, or we can think of the intensity, about the intensity, taking in consideration the maximum temperature or the cumulative temperature, etc. Right? So we are doing this. We are using the bar plot to plot different parameters of intensity in marine heat waves. So as you can see here, in the three plots we obtained, the lines are the same in every plot. We have the same events. We are now analyzing the same events, but the intensity of each event could be defined in different ways, right? For example, we see that, let's focus in 2005, which is the year we are interested in. We can see that in 2005, we have few events. As I said before, there are 4 events with quite high duration, with a maximum of intensity that is clearly outstanding in our time series, and also with the quite high values of cumulative intensity, right? So clearly, the year 2005, it was a year with a strong affectation of marine heat waves. But if we look at the red lines, we realize that actually in 2010 we have the maximum duration of a marine heat wave. There was a marine heat wave that has lasted for more than 100 days. And also we have the maximum of cumulative intensity in this marine heat wave. So we could think, okay, 2010 is also a interesting year to analyze in these terms, because probably 2005 is very well described by bibliography, but maybe 2010 occurred something very strong that we do not have information about it. And I think it's also interesting to see the period 2020, the year 2020, where, as you can see, there is an accumulation of events really, really high. They are very, very close. All the dots here are very close. So maybe it would be interesting to go over 2020. In this case, and just to finish the tutorial, I want to go to go over the year 2010, and see what happened in this year, right? So we can go back to the cell where we are defining the period we want to analyze, and we can change the period we want to analyze. For example, we can change 2005 by 2010. And run again the cell, and since in the 2005 we have 4 events. In 2010 we detect 6 different marine heat waves, and we can plot this result in the plot we did, in a similar plot that we did in 2005, using this cell, running again this cell. So, well, this is what we have. As you can see, 2010, it was almost as impacted by marine heat waves, as it was 2005. You can see that in 2005, actually, the high values of temperature started not in February, but even in January, in the middle of January, we started to get high values of climatical values of temperature that lasted for all the winter and all the spring until the summer. So, well, it could be interesting to go over this period and see what happened with corals, and we have some markers of how to detect periods of time that could affect the health of the ecosystems in Caribbean Sea or in other sea over the world, right? Well, this is the tutorial. I think as last in this tutorial, we have seen how to download data and use the data, and also use external functions, Python functions, to make computations. As I said before, at the end, the most of the work can be done after you download the data. You can download the data from Copernicus services, and after that you can make lots of computations and make lots of statistics to get the conclusions you need. As final exercise, I proposed this because, as I said before in the beginning, we had very, very high values of temperature in the Gulf of Mexico, for example, in this period in 2005. So maybe it could be interesting to go over the Gulf of Mexico in this period and see what happened this year in the Gulf of Mexico. So I propose to do this, since we do not have in this file, we do not have information about the Gulf of Mexico. We have to go back to the beginning of the tutorial and start downloading the data we need to analyze the Gulf of Mexico, right? So we have to download a specific region in the Gulf of Mexico. And I propose this location, 27 degrees and 80 degrees west, but you can go to any place you want. So you can download this data and run them all, and run all the cells, adapting everything you need related in latitudes, longitudes, etc. And well, this is, I think, quite interesting exercise that could give you information of how to work and compute marine heat waves.
Yes, thank you, Alvaro. We hope this was a very interesting tutorial for you. As we said, as you've seen through Alvaro's tutorial, this is a little bit more specific on the data and how on a study specific. I find this one very interesting, particularly. So we hope you can, if you were not able to follow along to do it on the site, just don't worry, you will be able to practice it. To practice on your own later on, once you can have access to the Jupyter hub.
Yeah, I think it's interesting to go slower over the Jupyter notebooks, reading everything and taking time to see the code and everything. At the end, the code is not as, if you are familiar with Python coding, this code is not as complex as it could be in a first view. But obviously you need to go slow,
step by step, right? Yeah. Yes, but it's already good. I think that the participants will have the chance to see the replay of this session, and then we'll have your explanations, right? So they can go back and have the explanation for each line, for each code line. Okay, so we have time for 1 or 2 questions. The first one, is there available repository of existing data on heatwave analysis and forecast free for download for research purposes?
In
Copernicus.
If any university could provide this, but as far as I know, there isn't. You go with these tools, you can go over the region you are interested in, and as you can see, you can have the full record of the marine heat waves in the region you are interested in.
Yeah, you kind of have to do it the separate download yourself, right, of the parameters you need.